For my physics project, I'm going to talk about the Margnus effect. The Margnus effect is used to explain the physics behind all rotating balls. Today I'm going to use the Margnus effect to talk about the physics of soccer. I'm going to experiment this by placing the ball right there in the corner and getting it into the goal. You may ask, how are you going to do this? It's a straight trajectory. What happens is when you kick the ball off center, it causes the ball to spin. The friction between the air and the ball causes the ball to curve, which will make the ball go into the net.
The ball traveling one direction has air flowing at it in the opposite direction. This airflow creates a thin layer of air dragged around the ball. On one side of the ball, air flows in the same direction as the spin. This air gets dragged along and accelerates, creating an area of low pressure. On the opposite side of the ball, airflow moves in the opposite direction as the spin. This air cannot move around the ball, so it separates and decelerates, creating an area of high pressure. The difference in pressure creates the Margnus forces that causes the ball to move from high pressure to low and creates this curved trajectory.
Now that we've explained the basics of the Margnus effect, we're going to conduct an experiment to see how different size radiuses and masses affect the Margnus effect. We're going to have to do this in two experiments because you can only solve for one variable at one time. So the first experiment is going to have balls that all have the same radius but different masses, and the second experiment is going to have balls with different radiuses but similar masses. These are the four balls we're going to use to experiment on the different masses. How we're going to experiment this is we're going to kick the ball and see how far it goes out and how far. Then we're going to map theta, and we're going to plot mass and theta and see how mass increases, if theta increases or decreases. In our experiment, this one had the lightest mass, and it didn't work with curving, so we're going to avoid this in our data points and just map the other three balls.
These were the results for how the Margnus effect was influenced by different masses. In conclusion, as mass increased, theta also increased with a positive linear relationship.
The second experiment is going to test how different radiuses will affect the Margnus effect. So these three balls will be used, and we'll track the data points the same way, with mapping how far it goes out and how far it goes out this way, and then mapping theta versus radius.
These were the results for how the Margnus effect was influenced by different radiuses. In conclusion, as radius increased, theta decreased with a negative linear relationship. In this experiment, the assumption is made that all the balls were hit with the same initial force. This is why we use the same person to kick all the balls in every trial. Other modifications that could be made to this experiment in future trials would be accounting for the height and the material of the ball used. Although physics cannot make you better at soccer, I hope this video gave you a better understanding into the aerodynamic forces of the Margnus effect and the physics behind bending the soccer ball.